Hello, grade 12. So today is lesson 8.2, which is an extension of yesterday's lesson. So yesterday was adding and subtracting functions, and today is multiplying and dividing functions. So 8.2 is called products and quotients of functions. So a combined function in the form of y equals f of x times g of x represents the product or multiplication of two functions. F of x and g of x. A combined function in the form of y equals f of x over g of x represents the quotient or division of two functions, f of x and g of x, where g of x cannot equal 0. Alright, so we're going to let f of x equal x plus 3 and g of x equal x squared plus 8x plus 15. So first, letter A, we're going to find an equation when y equals f of x times g of x. So we need to find a combined equation. So we're going to insert f of x in the place of f of x, that's x plus 3, times g of x, which is x squared plus 8x plus 15. So we're going to start by factoring this quadratic. So we need two numbers that multiply to 15 and add to 8. So that would be 5 and 3. And now we can simplify this by combining the x plus 3 and the x plus 3 to be x plus 3 squared times x plus 5. So therefore, f of x times g of x equals x plus 3 squared times x plus 5. Okay, then how would you graph this? So in order to graph this, we would use the zeros. So x plus 3 equals 0 and x plus 5 equals 0. So our zeros are going to be x equals negative 3 and x equals negative 5. Since x plus 3 has this little squared, that means it's going to be in order 2, 0. And if you recall back to the beginning of this course, that means it touches the x-axis and then it bounces back off. So something like that, if that would be negative 3. Okay? So looking at a graph, so our zeros are going to be at negative 5 and negative 3. So if we just go up by ones, and then we don't really know what our scale needs to be on the y-axis yet. So in order to get an idea of that, we can find the y-intercept. And the y-intercept can be found when x equals 0. So into this function here, we're just going to plug in 0 for x and find the y-intercept. So 0 plus 3 squared times 0 plus 5. So that's 3 squared times 5 equals 9 times 5 equals 45. So the y-intercept will be 0, comma 45. So on our y-axis, we need to go up to at least 45. So if we go up by tens, and then down by tens. All right, and then I'm just going to plot my points. So I had a 0 at -5 and a 0 at -3. Now we need to figure out which direction this goes in. So this is a degree 3 function because it has an exponent of 2 and an exponent here of 1. And it has a positive a value, positive 1. So that means it starts down here in quadrant 3 and it goes up here to quadrant 1. So it starts here, goes down to that -3, bounces off, and then it's going to go through 45. And this is f of x times g of x. Okay, and then we just would like to know what the domain and range of this is. So the domain, which x values are possible for this function? Well, all of them, we can have any on this x-axis. So x is a member of the reals. And the range, which y values are possible? Well, we're going down to negative values and up to positive values for all y values are possible. Y is a member of the reals. Okay, the next part is we're going to divide these functions. So if we have y equals f of x divided by g of x, we'll plug in our two functions there. So x plus 3 divided by g of x, which is x squared plus 8x plus 15. Again, we're going to factor the quadratic. So now we have x plus 3 over x plus 3, x plus 5. We can cancel out the x plus 3's, and that just leaves us with 1 over x plus 5. So since we've canceled out that x plus 3, that will leave us with a whole at x equals -3. To find the coordinates of that whole, we will plug in -3 into the equation. 1 over -3 plus 5 equals 1 over 2. So the coordinates of the whole are -3, 1/2. Okay, so this is a rational function, and the transformation from this function, the d value is -5, so it's just going to be shifted 5 units to the left. So if we graph that, we will go up by tens. And then on the y-axis, we'll go up by ones as well. So let's start by drawing our vertical asymptote. Remember, a rational function has a vertical asymptote. So set the denominator equal to 0, x plus 5, and that will give us the vertical asymptote, which occurs at -5. And then we have a whole at -3, 1/2. There. Now we can draw our function. Remember that rational functions also have a contact at y equals 0. So this is the graph of f of x divided by g of x. The domain and range, which x values are possible for this? Well, not -5 because it's our vertical asymptote, and not -3 because there's a hole there. So everything else, x is a member of the reals such that x cannot equal -5 or -3. But everything else is possible. And the range, we have a horizontal asymptote at y equals 0, and that hole is occurring when y is 1/2. So everything except 0 and 1/2. Y is a member of the real such that y cannot equal 0 or 1/2. Alright, so next we're going to be doing a word problem, and this is from your textbook on page 436. This is number 6 and 7. We're just going to be doing some parts of it. So the question reads this. A fish pond initially has a population of 300 fish. When there's enough fish food, the population P of fish grows as a function of time t in years, as P of t equals 300 times 1.05 to the power of t. The initial amount of fish food in the pond is 1,000 units, where 1 unit can sustain 1 fish for a year. The amount F of fish food is decreasing according to the function f of t equals 1,000 times 0.92 to the power of t. So letter A says to graph the functions. We're not going to do that part. Letter B says determine the mathematical domain and range of these functions. So this is letter B. Our population function is P of t equals 300 times 1.05 to the power of t, and our food function is f of t equals 1,000 times 0.92 to the power of t. So for the population, let's think about the domain. So t in this case is time, and time can't be negative. So the domain is going to be a positive number. So t is a member of the reals such that t is greater than or equal to 0. And then the range is representing y, or p in this case, which is the population. The population starts at 300 fish. That's the initial amount, and it's increasing from there. So p is a member of the reals such that p is greater than or equal to 300. For the food equation, again, t is representing time. So the same thing, time can't be negative. So t is a member of the reals such that t is greater than or equal to 0. And the range, this is representing the food. The food starts at 1,000 units and it's decreasing. So f is a member of the reals such that f is less than or equal to 1,000. But really, it doesn't go below 0, right? Because once you run out of food, you're out. So f is between 0 and 1,000. All right, letter C. Identify the point of intersection of these two curves. Determine the coordinates to 2 decimal places and explain what they mean. Call this point in time the crisis point. So the point of intersection if you recall from grade 10, we can find the point of intersection of 2 equations by setting them equal to each other. So if I have 300 times 1.05 to the power of t equals 1,000 times 0.92 to the power of t. Now I need to solve for t. So I'm going to start by dividing both sides by 1,000. So these ones will cancel out. 300 divided by 1,000 is 0.3 times 1.05 to the power of t equals 0.92 to the power of t. Now I'm going to divide both sides by 1.05 to the power of t. And now I have 0.3 equals 0.92 to the power of t divided by 1.05 to the power of t. And if both of these are to the power of t, that means I can put them in brackets and make the whole entire thing to the power of t, because that power applies to each term in that bracket. So now I'm going to take the logarithm of both sides. Log 0.3 equals log 0.92 over 1.05. That's all to the power of t, but remember that log allows me to bring that t down to the front. And now to isolate t, I'll divide both sides by log 0.92 divided by 1.05. If I put that into my calculator, I'll find out that t equals 9.109, or that could be rounded to 9.11. And that's time in years. So that's the point of intersection, or that's the x-coordinate of the point of intersection. Now to find the y-coordinate, I need to plug it back into one of the original functions. So I'm going to choose the population function. So p of 9.109 equals 300 times 1.05 to the power of 9.109 equals approximately 467.88. So that means the point of intersection is 9.11, 467.88. And that's called the crisis point. So this is the point in time where the fish population equals the food quantity available. There are as many fish as there are units of food. So there's exactly the right amount. And that's why it's called the crisis point. Because if the food goes any lower, there won't be enough food to feed all the fish. Okay, moving on to 7. 7 says, graph the function y equals f of t over p of t on a different set of axes. What does this function represent? So we're not going to graph it, but we are going to say what it represents. So the food divided by the population means that this function represents the amount of food available per fish. This function represents the amount of food available per fish. All right, letter B. What are the coordinates of this function at the crisis point? So if we determine what f of t divided by p of t is, then plug in 9.11, which is the crisis point, then we can find the y-coordinate. So y equals f of t divided by p of t. So we'll do that division. So equals 1,000 times 0.92 to the power of t divided by 300 times 1.05 to the power of t equals 1,000 divided by 30 can be simplified to 10 over 3 times 0.92 over 1.05 to the power of t. And now if we plug in 9.11, which was the crisis point for these functions, t equals 9.11, we'll plug that in for t. So that equals 10 over 3 times 0.92 over 1.05 to the power of 9.11. Plug that into your calculator and you get 0.99988, which rounds to approximately 1 unit of food per fish. So this question also says, explain the meaning of these coordinates. So that means that at year 9.11, there will be 1 unit of food per fish left in the pond. And then letter C, describe the living conditions of the fish before, at, and after the crisis point. So before the crisis point, there's extra food. The fish had lots of food. During or at the crisis point, there's just enough food. And after the crisis point, there's not enough food. So some fish are going to start dying. So hopefully this is pretty clear for you. Let me know if you have any questions and have a good day.